Is the Algebra 2, Chapter 2 study guide, okay? In this chapter, we dealt with domain and range of a relation or a function. Remember that domain are the x values and range are the y values, okay? So seeing things as ordered pairs, we have range values of 3, 0, 4, and -1 for this first one. 3, 0, 4, and -1. And our range values, or our domain values, sorry, are -2, 1, 4, or 1, and -1. -2, 4 is not 1. 1, 1, and -1. You don't have to repeat the ones if you don't want to. To specify if a function is, or a relation is a function, keep in mind that the same x, all x values can only have one y value. One y value for a function. Okay, so we have -1 going to 0, or +1 going to 0, and also 1 going to 4. That tells me that it's not a function. -1 to 0, and, sorry, I'm not getting this down right, and 1 to 4 makes it not a function. It can't have both those y values. Okay, another way to see functions is through graphs. And with these, the domain and range is a little harder to find. Remember that each of these points represents a coordinate. So this is 3 and 4, and this is 2 and 1, and this is 1 and -1, and then we have -2 and -1, and we have -3 and -1. So writing it out like that, you can see the domain values: 3, 2, 1, -2, -3. Use green as well for this. So 3, 2, 1, -2, and -3. Range values, again, are the y coordinates that correspond. So 4, 1, -1, -1 again, and -3. Not sure why I had a typo here. That's -3. I'm just all over the place. Okay, this one is a function. One way you can tell is all the x values have different y values, and this also passes the vertical line test. So the vertical line test is how you can tell through a graph. Okay. Linear functions. Linear functions are always of the form y equals mx plus b. Mx plus b, not x squared, 1 over x, 1 over x squared, anything to a negative power, also absolute values. None of those are linear functions. Okay, so for number 3, it is nonlinear, and that's because of the x squared. When we're evaluating these, it's as easy as plugging -3 in for x squared. So 2 times -3 squared plus 3. If you're going to use your calculator, I always tell students, put the -3 in parentheses. It does make a difference if you don't do that. So evaluating, we get 21 as our solution. Alrighty. This next one, 2x minus 1, this is linear, and that is able to be told because this is just y equals mx plus or minus b. Okay, so that is linear, and when we evaluate it, it's just 2 times 2 minus 1, which is 4 minus 1, which is 3. Alrighty. Other examples of nonlinear functions, I wrote those up above here. X squared, anything x to the third, x to the fourth, so forth. 1 over x, 1 over x squared. If you have a negative exponent, like -3 or so forth, and absolute values of x. Okay. Steeper, show your work. Steeper, we're all dealing with slope formula. Slope formula is m equals y2 minus y1 all over x2 minus x1. I think it's helpful to label these things. So x2 and x1, and also y2 and y1. And feel free, you can just write on top as well. So like here's x1 and y1, and here's x2 and y2. That can be helpful. So when we substitute these values in, we have -1 minus 5, y2 minus y1, all over 2 minus -1. Be careful with this down here. Minus and negative is positive, so 2 minus -1 is 3. -1 minus 5 is -6, and our slope is -1/2. So it's a fall of -1 and a rise, or in a movement to the right or left, too. Our next line here, 4 minus 2, all over -5 minus 4, is going to be 2 over -9, and that's just all that is there. To see which is steeper, it's going to be the smaller decimal, okay? The smaller decimal is going to be less steep. So here we have -0.5 and 2/9. It doesn't really matter which is negative or positive. We have 0.2 repeating, and if we actually graph these as well, say we have a slope of -0.5x, and the other one is -0.2x repeating or so, that's okay. If we graph them, you'll see there's the first one, and there's the second one. So the smaller decimal is less steep. And the larger decimal is more steep. So line 1 is going to be steeper in this case. Okay, find the slope of the line passing through given points. Show your work. So slope again, 2 minus 2, y2 minus y1, 3 minus 4. Here's a special one because we had 0 over 1. A 0 over 1 is a slope of 0, which means it's a horizontal line. It's horizontal. Key thing with that. Fractions. Oh, fractions are scary, but we'll make it okay. 1/4 minus 1/2 all over 5 minus 6. You're going to use your calculator. Make sure when we do 1/4 minus 1/2, it'll give us a decimal, and we can rewrite that as a fraction. Math, enter, enter. And up top we have -1/4. So do these piece by piece. I know it takes a little more time, but it's okay. 5 minus 6 is easy because that's -1. And -1/4, doing it in my calculator over here, divided by -1 is going to be just positive 1/4 or 0.25. So that is the slope. And remember that rising slopes are positive. So it is rising. And I'll write those down here for you to remember. Key things to remember with slopes. Slopes of 0 are horizontal. And you'll also notice that they have the same y values. So notice when these were horizontal, we had 2 and 2. Those were the same. As for undefined slopes, those are vertical, and they're going to have the same x values. Some other slopes to remember, just rising, they are any positive numbers, and falling are negative. Okay, so that's slope in a nutshell. More applications of slope. Snow. Fortunately, it hasn't snowed much recently here. 2 a.m. you measure the depth of the snow in your backyard to be 7 inches. So we can actually kind of set up a coordinate point. We have at 2, it's 7 inches. So this is our x, and snow is our y. At 10 a.m., measure the snow to be 19 inches, so 10 to 19. Okay, using our slope formula, 19 minus 7 all over 10 minus 2. 19 minus 7 is going to be 2. It's going to be 12, sorry. And 10 minus 2 is going to be 8. And if we type in 12 divided by 8, the snow is falling at an average rate of 1.5. We can say inches per hour. Okay, and with units, we have inches up top, and we have time, hours down below, and that's how you get the inches per hour. Without graphing, the next step, tell whether these lines are parallel. Parallel have the same slope. Perpendicular have opposite reciprocal slopes. And if it's neither of those, then it's neither. Opposite reciprocal slopes are things like 1/2, and we say it's perpendicular to -2. So this is what I mean by reciprocals. And you also need to have the opposite, one positive, one negative. Another example, say we had -3/4. It would be perpendicular to positive 4/3. Okay, basically, we are focusing on the number in front of the x. That is our slope. So when we look at 1/2 x down below in line 2 and 2x, we are comparing 1/2 with a slope of 2. And almost perpendicular, but this would have to be negative. So these two slopes are neither. Slopes are just different and not parallel. That's the symbol for parallel, or perpendicular. For number 10, you just have to solve for the slope first. So imagine if we were making this into slope-intercept form, we would have -2y is equal to -3x, and then we'd have y is equal to 3 over 2x. If we solve the next one, we would have 6y is equal to -4x plus 5, dividing by 6. We have y is equal to -4/6, which is the same as -2/3, x plus 5, and 3/2 and -2/3, these are perpendicular slopes. So L1 is perpendicular to L2 in that case. Remember again, parallel lines have slopes that are the same. Perpendicular are opposite reciprocals and reciprocal. Graphing, you can use any method. Calculator is always a great one here. But really, what we have in our first case is we're at -1, and we're going up 3 over 4. And you can connect those with a regular old line. If you have to solve or graph something from standard form, 2y is equal to negative 5x plus 12, divide by 2, and then y is equal to negative 5 halves x plus 6. I'll show you this one in the calculator. If we go to y equals, and if we type in negative 5 over 2, don't forget the x, and plus 6, yes, you can see what it looks like. So here is what the graph looks like. But you can also go to the table in your calculator, and that is just another way to help you. You might be okay with using 6 as your y-intercept, but here we have the 0.06, and we also have the 0.21. And if you want to get a third one, you're just looking over in your table to find the points that are nice whole numbers. So 0 to 6, which would be up here somewhere, which doesn't help us much. 2 to 1, over 2 up 1, and over 4 down negative 4. Whoa, super zoomed in. Sorry about that. To negative 4, we got those connect the dots, bada bing, bada boom. Okay, another one to try with the table in your calculator. Solve for y first. 2y is equal to negative 3x plus 7. Y is equal to negative 3 halves x plus 7 halves. It's a little funky because our intercept's decimal. That's where we can use our calculator. Type in negative 3 halves x. Oops. Too many x's in there. Plus 7 halves. And that's just how you can type it in. If you go to the table, second graph, it's going to tell you some more points. So from our table, we have 1 to 2, then we have 3 to negative 1, and if you want to get one more point, why not 5 to negative 4? That will help you match those up. Over 1 up 2. 3 to negative 1. And 5 to negative 4. And it always is a good idea to check to see if what you have matches up with what, or is at least going in the right direction with what your calculator says. As long as you solve for y in the right way. So graphing, slope, then we get into writing equations of lines. And it's all using these two formulas. Okay. Basically, different cases you'll have is if I give you a slope of 2, we know m equals 2. And y-intercept, that's b, equals negative 3. We can just put right into y equals mx plus b, and we have y is equal to 2x minus 3. Done. If I give you a slope and a point, you need to use point slope, which is this formula, y minus y1. So y minus the y1 is 8 is equal to m, which is negative 1/4 x minus negative 6. You'd be careful with a few things. This is going to really be x plus 6, and then the negative 1/4. Distribute the negative 1/4. This would be negative 6/4. We'll leave it like that for now. And then we can add 8 to each side. And it's going with the other constant, so not the x. And another time you can use your calculator. So we have negative 6/4. And we are adding 8, which is 6.5. If we make that a fraction, it's 13 halves. So the equation is y equals negative 1/4 x plus 13/2. Through 2 points. First, we have to find the slope. So -2 minus -1 all over 2 minus 4. -2 minus -1 is going to be -2 plus 1, which is -1. 2 minus 4 is 2, -2, which means our slope is 1/2. Once we have our slope, you can use either point. I'll use the first one, y minus -1, and we're using point slope form, the slope we just found. So the 1/2 and x minus 4. So we have 1/2 x distributing 4 times 1/2 is going to be -2. Notice this becomes y plus 1. So when we subtract, it's y is equal to 1/2 x minus 3. And that's those there. Okay. Trickier, but really not all that tremendously difficult, is writing lines that are parallel. Parallel, again, means the same slope. So we're referencing the slope from the given line, and we want it to be parallel, meaning we want the slope to be 2. Once you make that decision, it's pretty easy. Y minus -4 is equal to, we know the slope has to be parallel, so we're going to use 2. And then x minus 2 from our point, x1 and y1. So we have y plus 4 is equal to 2x minus 4, and if we subtract 4, we have y is equal to 2x minus 8, and those would be parallel. Perpendicular, similar, only now we need to find the perpendicular slope to -3. Its perpendicular counterpart is going to be positive 1/3. Remember, opposite reciprocals. Once you decide on that, it's just an exercise of y2 minus y1, or y minus y1, and 1/3, x minus 3. We have 1/3 x minus 1. Add the 2 over. So y is equal to 1/3 x plus 1, and those are perpendicular. Okay. Direct variation relates x and y given y varies directly as x. Anytime you see that, you want to think y is equal to k times x. Okay, and basically it's a substitution. So we have 8, that's our y value, is equal to some constant, we're actually solving for k, over -12. So what that means is 8 over -12 is going to be our direct variation constant, and 8 divided by -12 is 2/3, -2/3. So k equals -2/3. The equation then is y is equal to -2/3 times x. From there, you can evaluate. So now we're finding x when y equals 6. With our new equation, we can find y is equal to -2/3 times 6. And that might just be, okay, 6 times -2 is 12 over 3. That would be -4. Be careful. Sometimes you're finding, so maybe we need to find y. And actually, I did this one backwards. I just found y when x equals 6. I did a constant mistake students make. So that's actually this example. And if I'm finding x when y is 6, Mr. Dvorsky made a little mistake, but he's fixing it now. That just means you're plugging 6 in for y, and you'd have -2/3 for x. And remember to cancel out a fraction, we multiply by its So it's going to be negative 18 over 2, which is negative 9. So be careful with which one you are finding. I just found y equals negative 4 when x equals 6. So that again was the first one. Little typo. Where this comes into play are some word problems. Don't let them scare you. It's just every 6 hours a machine makes 36 parts. So hours are always going to be your x value. So what we have is that 36 is equal to some constant times 6. And when we divide, we get the constant is 6 parts per hour. So how many parts can be made in 48 hours? If we simply have y is equal to 6 times 48, that will tell us how many parts can be made in 48 hours. Sometimes students have different ways to think about those, which is fine. 288 is what the number of parts is. As for direct variation, the origin is always a point on the graph. Always goes through the origin. Each input value of a function, there is never more than one output value. The graph of a direct variation equation sometimes has a positive slope. It could actually have either. And a function is always a relation. So be wary of some of those. There's some multiple choice questions that are similar. Points lying on a graph. These type, use your calculator. If we go to y equals and we type this equation in, 8x minus 2, and we go to the table, you're basically looking for which of these works out. 322. I see that one's on there. Is 214. Yes, that one's on there. And 814. Let's go down to that one. No, that one is not on the graph. And 61 is not on the graph. So both of those from the table in your calculator. Which one of these equations represents the graph shown? There's actually a typo with this one. Typo. None of these represent it. Just skip over that. Saving money for new cell phone. Now you have 30 save. You save 15 more each week. Here's the function. Models the amount you can have saved after W weeks. So what's the total amount saved after 5 weeks? Basically, that just means after 5 weeks, and this is an S, that's 5, we would just be plugging in 15 times 5 plus 30. 15 times 5 is 75, plus 30 is going to be 105. You do not need to divide by this here, just leave it go. 105 bucks is what you have left. How many weeks does it take to have 255? Here we're just going backwards. We're plugging 255 in for y, and we're solving for the number of weeks. And once you do that, 255 minus 30 is 225, and divide by 15, we get 15. 15 weeks, you can get your new cell phone. Alrighty. Last type of stuff is correlations. Okay, so drawing a scatter plot of data, really it's just x and y coordinates. So 1, negative 1, 2 to negative 3, 3 to 0, 4 to 1, 5 to 0, and 6 to 3. Your line of best fit, lines of best fit, they can vary. They should hit at least 2 points and kind of be in the middle. So I'm pretty lenient on that. Try and get through 2 points. Go through at least 2 points. And try and get it so that the points are all kind of scattered around the line. So this one's kind of close, this one's closer. It goes through those two there, and then that one's hanging out there. But for example, you don't want to pick this as your line of best fit. Okay, that line does not come close to some of those other points. Equation of the line of best fit. Here's where we can really use our calculator. So for this, you're going to go to Stat and Edit. Stat, Edit, put in the L1 column, you're going to put in the X values. In the L2 column, you can put in the Y values. And if you go to Stat, Calc, linreg, hit enter a few times, there is the equation. Y is equal to 0.857, about that, X minus 3. So notice, it's giving our equation AX plus B. A is 0.857, and the B is a negative 3. With that equation, we can just evaluate for different values. So estimate Y when X is 8, 0.857 times 8 minus 3 is 3.86. And so forth. Type of correlation does a scatter plot have? Here are some examples. Positive correlation is if the values are all going kind of up in a certain trend. Negative is if they're all going down. And no correlation is if they're all over the place and you can't tell. So our particular example would have a positive correlation because of that there. As for the strength, disregarding the R value, the closer they are to a line, the stronger. So this would be a strong positive. This, notice how they're strong or farther apart, would be weak. And we can see through ours, they're all pretty close. So I would be okay if you just said it's a strong correlation, or you could say something like a medium strong correlation. Okay, and that's pretty much it. That's chapter 2 in a nutshell. Watch this video, get in good shape for the test. I believe in you.